This is question number 5 of our calculus review. We have the graphs of f and g are shown. Use them to evaluate each limit if it exists. If it does not, put in does not exist. The limit as x approaches 2 of f of x plus g of x. So for a value of 2, we could see that this function has an open circle at 2 and a closed circle at 2. But since we are looking for the limit here, this is based upon this value of the open circle. As we are approaching x is equal to 2, that value here is, well, just 2. For g of x, when we're approaching 2, we could see the function crosses our x-axis here. So it has a point being 0 in this case. So 2 plus 0, this sum would equal to 2. For the limit as x approaches 1 of f of x plus g of x. So at 1, this just equals the value of 1 for f of x. And for g of x at 1, we could see we have a closed circle here, an open circle here. We're approaching 2 different numbers from the left or the right. So this one does not exist. So I'll write like this. Does not exist. So this one, we would not be adding anything for that one. For the limit as x approaches 0 of f of x times g of x. This then would be, as we're approaching 0, function f here is equal to 0. And g of x at 0 is equal to some fractional component above the 1. Let's round that to be about 1.5. But when we multiply that, that just makes 0 anyway. For the limit, for little d here, as x approaches -1 of f of x divided by g of x. So -1, we're approaching a value down over here, which is at -1. So g of x at -1, we are a value of 0. So -1 divided by 0, this one also does not exist. For the limit as x approaches 2 of x cubed times f of x. So 2 cubed times, for the value at 2, so as we had before, that value of 2 is the number 2. This would be 2 cubed times 2. So in our case, 8 times 2 or 16. And then this bottom one, the limit as x approaches 1 of the square root of 3 plus f of x. So square root of 3 plus, as we're approaching 1, that value of f was 1. So square root of 3 plus 1 is the square root of 4, or just the number 2. Thank you.